All right. So greetings, YouTube. So beautiful mind here. So we're starting chapter. Oh no, what did I hit? Sorry. So we're starting chapter 6. Hold on. Okay. So we're moving into chapter 6, analytic trigonometry. So let's take a look at it. So we're going to start with section 6.1, inverse sine, cosine, and tangent functions. So we talked about the graphs of sine, cosine, and tan, right? Do y'all remember that? Is that okay? So the graph of sine, so as a quick recap, right? The graph of sine. Where does the graph of sine start? Does it start at the maximum or does it start at the middle? Sine starts at the middle, right? And then it's 5 key points. So sine goes from the middle, then to the max, middle, bottom, middle, and it just keeps doing that pattern for the most part. The key degrees are, you got 0 degrees, 90 degrees, 180, 270, 360, right? So now, I'm just going to kind of go off the dome for right now for a little bit. So now, given a graph, how do we tell whether a graph is a function or not? If it passes what kind of test? There it is, the vertical line test, right? So if the vertical line test tells us whether or not a graph is a function. So does anybody know a test to tell whether or not a graph has an inverse? You know what I mean by inverse? It's like the reciprocal or a flip, right? Can you give me an example of, like, if I say addition, what's the inverse? Subtraction, right? If we say multiplication, what's the inverse of multiplication? Division. If we said squared, what would be the inverse function of a squared function? Yeah, so like a square root, right? So in that same sense where we have inverse functions like that, we have inverse functions of trig functions. So if we look at the trig functions, they all pass the vertical line test, right? Is that okay? So now, if the vertical line test tells us whether or not it's a function, what test tells us whether or not it has an inverse? Horizontal line test, right? So in a similar sense, in order for a function to have an inverse, it has to pass the horizontal line test. So what we mean by that, no matter where we draw a vertical line, it'll only touch the function once. If we can draw a vertical line and it touches it more than once, it does not have an inverse. So the following phrases are synonymous. Passing the horizontal line test, having an inverse, and being one-to-one, these all mean the same thing. So with that background, I'm assuming that the audio is working. If not, I'll make a video later. If we look at trig functions in and of themselves, like if we consider the sine, where it starts in middle, top, middle, bottom, middle, top, if we look at the whole graph of sine, does that pass or fail the horizontal line test? Sine. Does it pass or fail? It fails, right? Because sine is constantly going up and down. So if we look at the general graph of the trig functions, they all fail the horizontal line test. So within and of themselves, they don't have inverses. So what we have to do in order to consider inverse trig functions, we have to impose a restriction on the domain, right? So that way, now we're going to look at a portion of the trig functions, and now we're going to look at a portion that will pass. We're going to force it to pass the horizontal line test. So some objectives here is find the exact values of inverse sine function, approximate values of an inverse function, properties, so on and so on. We'll let that be. Okay, so some properties of inverse functions. When we say f inverse of f, can I go like this? When we say f inverse of f, we should get x, and vice versa. If we say f of f inverse, we should also get x, right? So we verify that two functions are inverses of each other. If we say the first compose the second, we get x, and if we change the order, the second compose, that was an intense, man, I was like, I could feel that. If we reverse the order, the second compose the first, so we get x, then that means that's how we verify that two functions are inverses of each other. The rest of this I'm going to kind of talk about in the flow. So again, this is kind of touching on the idea that we were discussing. If we consider the graph of sine, the original graph, it fails the horizontal line test. You see that? So we're going to impose a restriction on the domain of sine. The blue part identifies the restriction. So we restrict the domain, the x-axis, from where to where? From negative pi over 2 to pi over 2. Right? So in terms of degrees, what degree measure is that from? Negative 90. Right? So whenever we do inverse trig functions, I always kind of keep that blue image in my mind. In my mind, I was like, and I'll usually put it off to the side. I say, okay, I know we're restricting sine from negative 90 to 90. Tell me about the range of that restriction, the bottom to the top. Is that okay with everyone? Can we start in attendance, please? Thank you. So we're restricting the domain of sine from, I'm going to do this in degrees because I can visualize that a lot better. We're going to restrict the domain of sine from negative 90 to 90, and that the corresponding range is negative 1 to 1. So if that's the restriction on f, when we consider f inverse, let's write this, do a quick annotation right here. What color are you feeling today? Red? Okay. So when we consider sine, I'm going to say sine of theta. For the domain, we're going to restrict that from, we said, negative 90 degrees to 90, up. Clean that up. All right, so we're going to say theta, let me see. Yeah, actually, let me be a little bit more consistent with their notation. Instead of theta, I'm going to use x. So when we consider sine of x, we're going to restrict x from negative 90 to 90, and then the range, we said it goes from negative 1 to 1. Is that it? Oh, I didn't want to do that, but that's okay. I can move it later. Okay, so that's for sine of x, right? Those are the restrictions. So when we consider inverse sine of y, can you tell me what's the domain and what's the range for the inverse sine? When we go to take the inverse, can you tell me the domain and the range if you had to guess? So, okay, we see the domain and range. Let's do this really quickly. We see the domain and range for the original trig function. Let's do this one. So when we consider inverse sine of y, what do you think is the domain and what do you think is the range? Thank you. You finished? Oh, it's extra. If you had to guess, in the spirit of a function and its inverse. Inverse, we said. So which one would you anticipate to be the domain, the top one or the bottom one? For the inverse trig function? The bottom one, right? So remember, in the spirit of inverse functions, it reverses, right? So if we're given the domain and range of the original, when we go to find the inverse trig function, those sets flip. So the domain of the inverse is going to be negative 1 to 1, and that's supposed to be a y down there. This is y. Y goes from negative 1 to 1. So now when we do inverse sine, the domain is, you see it on the bottom and the range is on the top. Let me do the following. Let me do my duplication technique. That actually worked. So this one, I want to get rid of this thing. Awesome sauce. And then this one, I want to get rid of this. Delete. That's good enough. And from the current slide. Come on. All right. Okay. So now when we do inverse sine, this is I automatically go to this image, right? The original is restricted from negative 90 to 90. Oh, actually, this is this the inverse? This is the graph of the inverse trig function. So our domain, let me think about it. Nope, this is the original. Sorry, scratch that. Yeah. So this is just the blue part from up top, right? So this is the original. So notice it's restricted from negative 90 to 90, and the range goes from negative 1 to 1. Okay. So y equals inverse sine. Now, we have y equals inverse sine of x. This means x equals the sine of y. So when we go to solve these, we're going to be using pretty much that domain and range, and then this property. Again, y equals inverse sine of x means x equals the sine of y. Okay, so we're going to be using that to kind of work through these. Given a graph, how do we obtain the graph of the inverse from the graph of the original? In a graphical sense. What were you going to say? I'm sorry. Given the graph of the original, how do we obtain the graph of the inverse?
You just find the domain and range of the normal graph.
Okay.
And then you just swap the positions.
It's not far off. That you can actually use that. One technique, if you had like the set of ordered pairs, like a table of ordered pairs of the original, When you want to find the inverse, you just switch those columns and plot those, and that'll be the graph of the inverse. In a graphical sense, given a graph f, f inverse is going to be the original graph rotated about the line y equals x. So the blue is the original graph. No. Sorry, the red is the original graph, right? If we rotate the red graph about the line, that diagonal line y equals x, we'll get our inverse function. So given a graph, to obtain the graph of the inverse, we rotate about the line y equals x. It's a little weird diagonal rotation kind of thing, okay? Let's see if we can work an example. So in this one, we're asked to find the exact value of an inverse sine function. Find the exact value of this, okay. Y equals x, okay. Let me do something really quickly. I wish I didn't show the answer, but that's okay. Let's duplicate this, and let's delete this. Delete. Okay, and let's delete this too. All right, let me see what I can do from my memory from the current slide. Okay, so now, whenever we're doing inverse trig, we kind of need to do the following. Let me kind of give it a go to see if I can remember. So if we consider the original, if we consider sine of x, the domain of sine, we said went from where to where? Negative 90 to 90. Is this okay? And then the range we just said went from negative 1 to 1. So then when we consider the inverse, so inverse sine of y, this is our range, this is our domain, okay? So that's the first thing that we kind of need to do when we do these. So then let's take a look at this one. So let me see, inverse sine. So if we have inverse sine of negative 1, we're going to set this equal to x. Again, this means what? The sine of x equals negative 1. Now, with that manipulation, can you tell me the sine of what angle gives us negative 1? Sine of what angle gives us negative 1? So now we're going back to like the unit circle. Remember the whole unit circle, the 1, 2, 3, 1, 2, 3? Okay. So can you tell me the sine of what angle? On the unit circle, is the sine, is that our x or is that our y? So on the unit circle, sine is our y. So where is y negative 1? At what angle? Not negative 360. Where's the y value negative 1? At what angle? That's positive 1. The y value is positive 1 at 90. Negative 90, right? Okay. So we usually do 270, right? But x has to be between where to where? Negative 90 to 90. Thank you, Mr. Train. You know, like, we have to do a petition. We have to do a petition. Like, that's the only way they will stop doing that. Like, but it's okay. We got to break the rhythm and energy. Like, the thing about being a black person, like, we deal with so much crap. We know how to, like, we're so flexible. I mean, we kind of do have our break and our limit points at times, but we can handle it. Like, we'll be okay. Okay. So yeah, now, if we're on a unit circle, the y value is negative 1 at 270 degrees, but we see the restriction, our domain, the x has to be between negative 90 to 90. So 270 is the same as, what did you say earlier? You said it earlier. Yes, you did. Negative 90, right? So 270 degrees is the same as negative 90 degrees, right? So then x is actually going to be, we're going to do negative pi over 2, just like that. It's like a reasoning. You have to kind of go back and forth, right? So again, we kind of went between the unit circle. We didn't really use the right triangle trigonometry that much here, but it was mostly the unit circle. And we used the graph of sine. So let me see if this is correct. Now, suppose I'm working on an exam and I want to check this before I go on, right? Suppose we want to check the inverse sine of negative 1 is indeed negative pi over 2, right? So let's go here. Yeah, trusty, dusty, rusty. I'm going to cancel showing all my stuff, but that's okay. I ain't got nothing to hide. All right, let's go let's open up a trusty, dusty, rusty. Reload and refresh. So let's reload. Okay. All right. So we're going to leave it in radians. So we can leave that. We're going to let's do inverse. So second inverse sine, we said of negative 1. we're going to get this decimal, right? That should be, what should that be if we're doing radians? Negative what? What answer did we get? Negative pi over 2, and notice it's the exact same. All right? Okay? So that's one way to kind of, get some kind of confirmation before going forward. Go ahead.
When the calculator, when you're trying to solve for radians, you're trying to turn.
We just did inverse. I just typed it in just like that, and I left it in radians. Like let me. Yeah, we had it in radians. We could have done it in degrees as well, right? So let's see how this evolves. So let theta equal inverse sine of -1. Then theta is the angle, some angle between -90 to 90, whose sine equals -1, and we found that it was -90. Okay. So yeah, this is basically talking about the unit circle. Our technique where we use 1, 2, 3, 1, 2, 3. That's what this is referring to. We typically do ours in degrees and then convert to radians. There are shortcuts for keeping it entirely in radians as well, but I think the degrees is simple enough. That's enough. We don't need to know all of them. We just need at least one route, and then once we're confident, we can find others. I had students. Yeah, I know. That's why I was like, let me just breathe, calm myself down. Because I was like, you'll see it. We just got to keep going. I got to not get hung up. I actually had a student that taught me how to keep it in radians and keep it simple. I don't know. They got a party going on out there. One is going that way. The other's like, no, I'm coming this way. Like, I don't know what they're doing out there. Okay. The only angle in that interval whose sine is -1 is -90. Oh, I got some money coming. My hand is itching. Y'all ever heard that? Mm-hmm. No. My hand be itching. Uh-oh. Let's keep our things. Let's duplicate this. And let's get rid of all of this stuff. Delete. We don't need any of this right now. No, it's not that. That one was okay. Now you can try it out. I would say try it out, but it's not always that straightforward. It's okay. Like, I want you to go ahead. If your first mind is saying you can do that, go ahead and try it out every time. But you're going to see where it's not always going to be that straightforward. But initially, that's okay, right? And I'd rather you do that. So that's because it's in radians, right? Okay. Now we're asked to find it, because again, if we put it in our calculator, it's going to give us a decimal. We don't want the decimal. We want the radian measure. We want the exact answer. We don't want an approximation. We want pi over something. You see what I'm saying? So you can use a calculator as a precursor. Now, if you put this in your calculator, what decimal do you get?
To the second decimal place is going to be 1.04.
I heard 1.04. That's not rounded?
It would be 1.05.
What's after the 4?
7.
What's after that?
1.
Give me a few more.
9, 7.
Okay. So when she put it in the calculator, she got this. Now, when we get on the exam, they're going to ask for exact values. So this is going to show us, hey, whatever exact answer we get, it should be equal to this, right? So let's do the same thing. Okay, so really quickly, let's do our original precursor. What color are you feeling? Green. Okay, I heard green and blue. Really quickly, whenever we do inverse trig function, it's a good idea to do the following. So again, sine of x, if that's the original, we said the domain goes from -90, and I know I'm going back and forth between degrees and radians, but -90 to 90, and then the range, we say it goes from -1 to 1. Is this okay with everyone? It's okay. So then when we do the inverse sine of y, this is our range, this is our domain. If we identify the domain and range first, when we talk about inverse trig, it's way easier. You see what I'm saying? Because I think we kind of locked in the green part. So then that makes it really easy to see the blue part. Okay, anybody colorblind in here? You know how to tell if you're colorblind? If you go to Google and type in like a colorblind test, you'll see them. If you can't see the image, you might be colorblind. And you don't really know until you take the test. Like you could be colorblind your whole life and you wouldn't know until you take the test. It's like unless you went to go do like your driver's test and then like the colors, you couldn't see them. I mean, it has implications, but some of my professors, they were colorblind and they were like, well, you know.
I don't know how it's like to be colorblind.
So it's something like missing a rod or a cone or something. So it's like everybody doesn't see the same thing. Like there's actually a video on YouTube, but it was originally about Vsauce. I don't know if it's still there. But they would ask these very like thought-provoking questions. They'll say like, how do I know that the red that I see looks the same as what you see? How do I know red in my eyes might not look purple to you? You know what I'm saying? Like, how do we know we all? And there's merit to this question because you have people that are like colorblind, and also there are people on the other end of the spectrum that see more colors that nobody else sees. There's a thing where, you know, some people they see sounds as colors, like they hear a sound and it makes all these colors for them. Those are real things. Anyway, it's just food for thought. Okay, okay. So now we're here. So now we haven't done. Let's do this color. So now again, inverse sine of the square root of 3 over 2. We're going to say this equals x. Again, this means the sine of some x equals the square root of 3 over 2. So the sine of what angle gives us root 3 over 2? Real quick, to recap the unit circle, the color we haven't used. Okay, so sine of what angle gives us the square root? So sine is what, our y. So if we do 1, 2, 3, 1, what angle is that? 30 degrees, right? Okay. Okay, so then our claim is that, I'm just going to kind of continue here. X equals 30 degrees, and then let's convert that to radians. How do we convert this to radians? Pi over 180 sounds good. Pi over 180 degrees. The units of degrees cancel. 3 divided by 18 is 1 over 6, so this should be pi over 6. So now, if we wanted to check, how could we check that these are equal?
Convert pi over 6 to decimals in the calculator.
Let me think about this. 1, 2, 3. Is that okay? Is that okay? How do we get pi over 6?
Because you want to find out what angle the sine of the negative 3, or radical 3 over 2.
Right.
We came up with 30 degrees. If you convert that to radians, it would be pi over 6.
So in the orange on the left where it says inverse sine blah 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 equals x. So that again, that inverse means sine of some angle equals root 3 over 2. What angle gives us root 3 over 2? So that comes from the unit circle. You remember the unit circle 1, 2, 3? Okay. So that comes from the unit circle. So then on the unit circle, sine of 30 degrees gives us root 3 over 2. Then we just converted 30 degrees to radians. And let's confirm this number. Let's actually see if this works. So we said what? Pi over 6? Pi over 6. We get this. And we did what? Inverse sine of the square root of 3 over 2. That looks good. We should get the same decimal. So did we make a mistake? Okay, let's go back. Maybe we did a calculation wrong. 3 pi over 6, 1.04. Okay, so that means we made a mistake, so we got to find it. Are we in radians? We are in radians. So the 1.04 looks good. So let's go back and figure out what did we do wrong.
I thought that's what it is right there.
Which one?
1.04.
No, but we want the exact value. The decimal is approximation. Let me think about it. Did I type it in properly? Let me go back and look at it again. Quit. We did pi divided by 6. Oh. No, that should be it. Let me look at this again. Hang on. So sine of what angle? So on the unit circle, sine is our y. We want what? Square root of 3. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3. Oh, it's 60 degrees. It's not 30 degrees, right? So here, okay, let's talk about this right here. So if we go back to the unit circle, right? This whole thing, this is 0 degrees, this is 90 degrees, here's our 45, this is like 30, this is 60. This is 30 degrees, this is 45 degrees, this is 60 degrees, right? So remember the whole shortcut? How do we do the shortcut again? Okay, all the denominators are 2 here. All these are 2, and then how do we do it? Just what's the quick? How do we? 1, 2, 3, 1, 2, 3, right?
Oh, yeah.
1, 2, 3, 1, 2, 3. And then what do we do with all the numerators? we take the square root of all the numerators. All right? So this one is 1 comma 0, this one is 0 comma 1, and this goes cosine theta, sine theta, right? So we want the sine of what angle to give us square root of 3 over 2. Sine is our y. So if we start in the upper left, we go 1, 2, 3, 1, 2, 3. We were supposed to do 60 degrees, and we had done 30 degrees. All right, so that's why we were getting it wrong. So let's back up. Let's fix it. So we're gonna get rid of this one. Get rid of that and that and that. Come on. So now, but see, that's how that goes though. We got that result. It didn't match up. So that was a flag. Like, wait a minute, we did something wrong. So we had to go back and slow down. Okay, so we should have done 60 degrees instead of 30. So, oops. Oh no. Whatever, that's fine. And then let's put this back. Okay, so now x should be 60 degrees. So let's convert that to radians. Pi over 180. Then what is that? Pi over 3, right? Boom. So that should be that one. Now let's check. So now if we go back to our trusty dusty rusty, second pi over 3, boom. But it was good that we made that mistake, because that's where all the power comes. Again, everybody makes mistakes. But it's in your ability to catch the mistakes and fix them as best you can, within time. Okay, that was good. Questions? Okay, 1, 2, 3, 1, 2, 3. Okay, going once, going twice, going on to the next one. Go ahead. Try. There it is.
So see where it says sine minus 1 over that equals x.
What color?
Orange.
Orange. Okay.
Is it always going to be equal to x?
Yeah, that's fine. I mean, x is essentially theta, but yeah, they usually do x. Inverse sine equals x. Yeah. Okay, that was fun. Let's do another one. So I think we did this one. So let theta. So x is the theta. We're kind of flipping between those two. So I think we got all that. Find an approximate value of inverse. So now we were finding exact values of an inverse trig. Now we want to find an approximate. Here to find an approximate value, express the answer in radians rounded to 2 decimal places. How do you think we're going to do this? If it says express the answer in radians rounded to 2 decimal places, how would you do this? What'd you say? Yeah, just calculate it, right? That's something like this. If it asks for an approximate answer, just plug it in the calculator. So if you plug this in your calculator, what result do you get? Oops. Okay, her inverse sine, what was the first one? Inverse sine of a third.
I got 19.47.
Let's see, inverse sine of 1 over 3. What units do we need to be in? 2 decimal places, 3, 3, 98, so 3, 4. So the first one, we got approximately 0.34. Is that okay? I feel like there's more to this. I'm gonna have to, as whenever I realize it, I'll share it. I think there is something more to this, but I'm gonna let this be. Okay, for this next one, I think I'm gonna do something a little bit more though. Yeah, okay. So what I'm gonna do for the next one, I'm actually gonna do the next one in degrees. Okay, so we got negative 1 over 4. I'm gonna do the same thing. I'm gonna do inverse sine of a negative 1 over, negative 1 over 4, but what I'm gonna do this in degrees. So I'm gonna hit mode so I can get a sense of what's going on, because I can visualize it better with degrees than radians. So if we do inverse sine of that, keep in mind this is a degree measure. So our angle needs to be from where to where? What's our domain? Negative 90 to 90. So then we can just take this one as is, right? This one should be okay. So negative 14 degrees is between negative 90 to 90. So we're just going to redo it again, but do it in radians. So I'm going to go mode, put it back in radians. And so negative 0.25. Oh, let's see, how do we do? I think this is okay. Approximately negative 0.25. Anyone want to contest it or got something different before we go forward?
No.
Going once, going twice. Why are you behaving like that? Oh, okay, it was zoomed in. Because the angles will be measured in radians, first set the calculator to radians, okay? We did that. I think that's what we got, right? 0.34, okay? And then negative 0.25 was the next one. Okay, so those were okay. They're not always that straightforward. Let's keep going. Okay, as an introduction, I think that's fine. Okay. Use the property of inverse functions to find exact values of certain composite functions. Okay. Now, so with this one, the main thing to focus on here is that the inside function determines our domain. For instance, if we look at the first line, sine is our inside function. What was our restriction on the domain of sine? Today when we opened the discussion, sine was restricted from, the domain was restricted from where? Negative 90 to 90. So because sine is on the inside, that one is restricted from negative 90 to 90. If you look at the second one, because inverse sine is on the inside, that one is restricted from negative 1 to 1. So that tells us what kind of answer we should be getting. Okay? Okay, we're going to let that be. So again, but that's all kind of determined by the inside function. Find the exact value of the following composite function. Can we just type that in? Exact value. Okay, so here, let's do this really quickly. Let's do the following. So again, if we consider sine of x, that domain went from negative 90, and here, just, yeah, this is fine for me, to 90. The range for this was negative 1 to 1. So then when we do inverse sine of y, this is our range, this is our domain. I know the x and y's are a little bit, just kind of be lax with that. I'm using it loosely, the x and y's right now. So now, which domain, should we use the top line as a domain or the bottom line as a domain?
The bottom line?
Why the bottom line? Remember we said the domain is based on the inside function. The original function is on the inside, so we should use the top line, right? So our answer needs to be between negative 90 to 90. I'm just going to put this in the calculator. Pi over 9. Let me see something. So I'm going to do inverse sine of pi over 9. If it's simple, we should just get pi over 9. So I'm just going to do pi over 9. I think that's fine. I can't think of anything else there. There is more to that, but this one is just pi over 9. I can't, well, we need to work a few more examples so I can kind of get you to see what I'm trying to get you to see. Okay. So let's just kind of let this one be for right now. Let's do this really quickly. Let's duplicate, and here we want to get rid of this stuff. Get rid of all of that. Delete. Did the attendance go around?
Yes.
Oh, it's here?
Yeah.
Okay. So yeah, so again, be sure to submit those assignments. I'm going to have to submit whatever grade I have until you submit it. Oh no, I don't know what I just did. I want to delete. Okay, and let's go back here from the current slide. So we got pi over 9 here. They essentially just canceled each other out, but it's not always that straightforward, right? So we're going to let that be for right now. Composite function of this follows from the property, because this is in the interval from negative 90 to 90, they just cancel each other out. Again, because the pi over 9 is between negative pi over 2 to pi over 2, we just take that number. All right? Is that okay? So the inverse sine and sine essentially cancel each other out. Okay, let's try another one. Okay, so now let's do our domain exercise again. Again, you kind of got to make it a habit. So if we did the sine of x, that domain went from negative 90 to 90, and the range went from -1, I'm going to do this, to 1. So when we do inverse sine of y, this is our range, this is our domain. Now with this, is our domain going to come from line 1 or line 2 in this case? Line 2 because the inverse trig function is on the inside. Remember the domain of the inverse trig function? Well, the first target you got to decide is the original in the inside or is the inverse on the inside? Because the inverse is on the inside, we use the second line. That's going to be our domain. Okay? So now that means our answer has to be between -1 to 1. Is that -2 between -1 to 1? No, so I think this has no solution. I think this one is, we're going to say no solution, or empty set or undefined, does not exist. Let's see, how do we do? It's not defined, right? So that's why I was like, let's do our usual duplication. I don't know about you all. I think I'm in my itis mode again. This like, okay, so being a professor, I don't know if other professors go through this, but I definitely do this. Because I'm a professor, like I'm in the academic atmosphere like year round. Every time we get close to holidays, I start getting the itis. Like I don't want to do anything. I just want to like eat and sleep and play. Like I don't want to do anything. It's like I'm not even here. I'm just thinking about the holidays, travel, you know. I just remember feeling like that as a student, and I still can remember. I get those same sensations as an adult. So the composite function that we're working follows from the property of composite functions. Since the domain of the inverse function goes from -1 to 1, inverse sine of -2.5 is not defined. So that's outside of our domain of the inverse. So therefore, this is also not defined. Does that make sense? Okay, so no solution, or that's not defined, or whatever. So that was an introduction to inverse sine. So the same kind of concept or ideas behind inverse sine is the same idea behind inverse cosine. Is this okay? So what do we notice about the restriction on the domain for cosine? No, the domain, not the range. So the 0 to 180. Is this okay with everyone? So notice for cosine we had to restrict it from 0. What would happen if we restricted cosine from -90 to 90? And we wanted to use the horizontal line test. If we restricted it from -90 to 90, does it pass or fail the horizontal line test? It fails the horizontal line test. So we pretty much have to go from max to max, max to min. So we go from 0 to 180. So we restrict cosine from 0 to 180. That's the domain. Let me see, is there anything? Okay. So it's a similar kind of discussion here. So if we consider, let's do cosine of x. The domain is going to go from 0 degrees to 180 degrees, inclusive. The range, can you tell me the range? The bottom to the top? So keep the order, -1 to 1, okay? So now when we do inverse cosine of y, what's the top one? That's our range, and the bottom one is our domain. I think this is fine. Okay? It's the same kind of argument with sine. It's just we had to shift it so that it'll pass the horizontal line test. Okay. Go ahead.
Notice how with sine we have -90 equal to or less than x or whatever. Why are we doing that for cosine?
We are. Y equals cosine x. That looks like a typo. That definitely. Yeah. Okay, so what's happening there? That's just talking about the domain of cosine by the original cosine with no restriction. So that -infinity to infinity is just a domain of cosine with no restrictions. The blue to the bottom on the right shows the restrictions, 0 to 180, with the equal to, less than or equal to, and all that, right? Okay, these are good questions. I know it's a lot, but I know you guys can handle it. It's funny, we got one guy. Huh? This Thursday, yeah. Okay, so we're going to essentially do the exact same thing with cosine with that shift in the domain, but everything else is essentially the same. So the red is the original graph of cosine with the restriction. The blue, if we rotate about the line y equals x, we get the blue graph. Like when I see stuff like this, though, that looks like artwork. What kind of shape does that look like to you? When you see this, what does it look like to you? I see two shapes. Just in the if just pictures, like when we removed. I see a bow and arrow. Do you see another figure? So like the bow and arrow is kind of like this. Like okay, so you have like this, you have this, that. He's like, his arm is coming like this, and then the bow and arrow. So it's a bow and arrow, but I also see this other image. Okay, yeah, the other one I see is something like this. What is that? A stingray, a mantis? So, but like when I see stuff like that, it just gets me excited about mathematics. Like, it's. I got some other stuff I want to share, but I'm just trying to stay on task. Because if I get lost, I will just be going on mental adventures all day long. Okay, so we're gonna let that be for right now. So we're asked to find the exact value of inverse cosine of a half. So let's try the same technique that we just did, right? Let's try the same technique like when we were doing sine. Where is my hello phone? Right here. Okay, so now if we consider cosine of x, that domain restriction we said goes from where to where again?
From domain
0 to 180, like this. And then tell me about the range. -1 to 1. Okay, let's do this color for this one. So when we do inverse cosine of y, this is our range, this is our domain. Is that okay so far? Thank you, Train. All right. I mean, it was like right. I know, it's ridiculous. Oh my God. I know. Okay, so now let's give this a go. So we're going to say inverse cosine of a half. It says find the exact value. Inverse cosine of a half equals, we're going to say equals x. Again, this means cosine of some angle gives us a half. So cosine of what angle gives us a half? Is cosine our x or our y on the unit circle? Cosine is our x. What angle gives us a half? All right, let's do it again. What color are you feeling? Let's do orange, right? So if we do the unit circle really quickly, right? We're looking at the quadrant 1. Here's our 45, here's our 60, here's our 30. So 45 degrees, 30 degrees, 60 degrees, 90 degrees, 0 degrees, right? Let's do our shortcut really quickly. So you can do this mentally. Sometimes you'll notice me look off because I'm doing this in my mind really quickly. I'm just going 1, 2, 3, 1, 2, 3. I know I'm looking for either my x or my y. All the denominators here are 2. Again, how do we get the tops? So 1, 2, 3, 1, 2, 3, and then we take the. Do you know what did you see? Yeah, square root. Radical. That's okay. That's okay. Radical square root. Okay. This one at the top is 0, 1. This is 1, 0, and this goes cosine theta, sine theta. That's fine. Okay, so now we're saying cosine of what angle gives us a half? So now can you tell me cosine of what angle gives us a half? 60. Okay. So x should be 60 degrees. And then let's go ahead and convert that to radians. So we're going to say over 1 times pi over 180. What is that, pi over 3? Is that right? Let's check our trusty dusty rusty. What answer did we get? Pi over 3, right? So let's go mode. We are in radians. We're going to do inverse cosine of what, a half? And then let's do pi over 3. Any questions there? So that was correct. Okay. Oh, let's do our duplication thing. So let's keep the ink. Let's duplicate. Is that the one? Yeah, that's the one. Let's duplicate it. Here we want to get rid of this thing. Yes. Delete. Let's get rid of this stuff. Come on. No, not that one. Yes. Delete. Awesome. This one, we want to get rid of this. delete. Awesome sauce. Okay, any questions here? Finally getting the hang of this. So here, really quickly. So let theta equal inverse cosine of a half. Again, this means cosine of some angle gives us a half. Again, the angle has to be between 0 to 180. I think we got an angle measure of 60 degrees, which is between 0 and 180. Then we converted it to radians. So this chart is our unit circle where we go 1, 2, 3, 1, 2, 3. That's what this chart is. So they're synonymous. The 1, 2, 3, 1, 2, 3 is this. Okay. So I know it's a lot. Don't be intimidated. Just do your best. Do your best. It is a lot. Like that's what I'm trying to. Huh? Those are the x-axis, the angles. Yeah. So but let's just keep working it. It'll sink in if we keep going. Just keep going. It'll sink in. I think we did all this, all right? Is that what we got? All right. Is that the answer that we got, pi over 3? Okay. Find the exact value of this one. Okay. So let's do our usual. Whenever we do inverse trig, we need to do our little thing over here. So we're going to say cosine of x, the domain goes from 0 to 180 degrees, inclusive. The range goes from -1 to 1. Is this okay? So then when we do, let's do this color. When we do nope. When we do inverse cosine of y, this is our range. This is our domain, okay? So let's do this. So we're going to say the inverse cosine of, we got a negative square root of 3 over 2 equals x. Again, this means the cosine of some x gives us a negative square root 3 over 2, okay? So can you tell me cosine of what angle gives us a negative square root of 3 over 2?
It's not 180.
Okay. Don't guess. Okay. Because you're throwing out, you're not. Cosine of what angle gives us negative root 3 over 2? Okay, let's look at this. Let's just do it. Notice, I'm doing this repeatedly. I'm intentionally kind of doing this over and over and over. Okay, so let's look at quadrant 1 again really quickly. All right, this. What is this? 45, 30, 60. This is 90. This is 0. This. So since we've been sitting here, I've done it like 3 times, right? So I'm just saying that for you to do it, because when you make it a habit of doing it, then it'll sink in. But just 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, like this, like this, like this, like that. Okay, and then this is our cosine theta. This is our sine theta. Okay. So cosine of what angle gives us, let's just start with the square root of 3 over 2. Cosine of what gives us square root of 3 over 2? 30 from here. But if we want negative square root of 3 over 2, what angle should we be at? So we restricted cosine from where? 0 to 180? So that means there's a quadrant 2 solution that also gives us the square root of 3 over 2, right? Okay, if we did negative 30, that's going to put us in quadrant 4. We do need to be 30 degrees away from the x-axis, but in quadrant 2. What angle is that that's 30 degrees away from the x-axis in quadrant 2? No. 30 degrees from the x-axis. So if this is 0, if this is 90, if this is 180 over here, right, 180, we need to go 30, the reference angle, right? 150. Is that okay with everyone? So what we did right here, so we're here, right? 30 degrees is here, but we need to be in quadrant 2 and 30 degrees like this. So what we're going to do is say 180 degrees minus 30 degrees to give us the 150 degrees. That's the quadrant 2 solution. That's the reference angle. Why didn't I just say what? Okay. Go ahead.
See, how I saw it is that counterclockwise.
Mm.
That's how we did it for the other side. So I would have put that 90.
Yeah, I mean, it's the exact same thing. Whenever we're 30 degrees away from the x-axis, cosine is root 3 over 2, sine is a half. We just have to straighten out the plus and the minus based on the quadrant, right? So on and so on for all of them. So from here, we get the x is 150. Notice that 150 is between 0 to 180. Let's go ahead and convert it to radians. So we're going to say over 1 times pi over 180. We divide them both by 3, 5 pi over 6. Okay, so we get this result. So we said x has to be between, so we said 5 pi over 6. So let's check it here. We said inverse cosine of a negative 3 over 2. Nope. Inverse cosine of a negative square root of 3 over 2. So I know it's a lot of back and forth. Okay. Mode, we are in radians. We're going to get our decimal. And we said what? 5 pi over 6? 5 pi over 6. Okay. We just have to keep working until it sinks in. It's, it's not trivial, but you can do it. Okay. So we check that one in the calculator. Let's do our duplication thing. Let's duplicate this. Let's get rid of, can we get it? Yes. Let's delete. Nope. Yes. Delete. Awesome. Okay, and then here we want to get rid of these annotations. Delete. Okay, from the current slide. Okay, so we're going to let that be. Let theta be this. This has to be between 0 to 180. So cosine of what angle gives us a negative root 3 from 0 to 180? Again, this comes from the unit circle. So now that technique of 1, 2, 3, 1, 2, 3, it actually takes us around the entire unit circle. I've just been focusing on quadrant 1, but you can use that technique to generate the whole unit circle, right? Whenever we're 30 degrees away from the x-axis, it goes, the root 3 over 2, comma, a half. Whenever we're 45, they're both root 2 over 2. Whenever we're 60 degrees, if you master quadrant 1, you'll see how it relates to 2, 3, and 4. So if you master quadrant 1, it's the exact same. You just have to straighten out the plus and the minus. Because x is negative in quadrant 2, y is positive in quadrant 2. You see what I'm saying? But it's the exact same thing. Okay, we're going to let that be.
I thought it was like, okay, so 2 is like negative x, positive y, then you go to 4, and it's positive x, negative
Yeah, that's fine. Yep, that's okay. That is perfectly fine. There's more than one way to do it. This is just how I'm doing it. Okay, I'm going to let this be. Okay, I think we got that result. The only angle, blah, 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 5 pi over 6. All right, let's let that be. So the same kind of thing here. Again, this is based on the inside function. In the first line, notice that the original trig function is on the inside, so that's why the restriction goes from 0 to pi. In the second line, the inverse is on the inside, so that's why that one goes from, that restriction goes from -1 to 1. Okay, so we're asked to find the exact. So if we're doing the same thing that we did before, we're doing cosine. So if we consider cosine of x, the restriction of the domain of the original went from where to where again?
0 to 180.
Okay, 0 to 180. We just got to keep in mind we got to convert at the end or whatever. Keep it consistent. The range goes from -1 to 1. Tell me about the inverse cosine of y. That's our range. This is our domain. They just flip. We just reverse them, right? Okay, so now, which domain do we use? Do we use the blue domain or the red domain? For part A. Do we use the blue or the red? Sorry, which domain? The top line or the second line? Top line. Because the blue is on the inside, right? Right? The cosine of x is on the inside, so we use the top line as our domain. So now we have to confirm that pi over 15 is between 0 to pi. Okay. Let's convert. I know, you just got to kind of keep working it. I'm going to convert pi over 15 to degrees. Ow. All right, let's do this. So if we said pi over 15 times 180 degrees over pi, the radians cancel. What's 180 divided by 15? Hey Siri, what's 180 divided by 15?
180 divided by 15 is 12.
So this should be 12 degrees. Is that from 0 to 180? So it checks out. So essentially these are just going to cancel, and x should be equal to pi over 15. So we'll come and check it in a moment. If we're looking at the second one, do we use the blue domain or the red domain?
The red.
Which one is on the inside? The blue is the blue on the inside or the red on the inside? Let me do this to be a little bit more consistent. So this one, let's do this in red. So this one goes from -1 to 1, right? So do we use the blue domain or the red domain?
Red.
Which function is on the inside? Is the blue on the inside or is the red function on the inside? Is the, for part B, yeah. The blue is on the inside. The blue is on the inside, right? Because the inverse trig is on the outside, the original trig is on the inside. So that means that angle has to be between 0 to 180. Is -3 pi over 4 between 0 to 180? Let's convert that to degrees to see where that is. Let's convert it. So now that we've identified, we're going to use the blue domain, the top line. Let's convert this -3 pi over 4. Let's convert that to degrees. This cancels. 90, 45, 45 times 3, 90, 135. Is that right? Hey Siri, what's 3/4 of 180?
3 over 4 times 180 is 135.
So, notice that the -135, we said we're using the blue domain. Is -135 between 0 to 180?
Yeah. Wait, no.
No, right? Right? Zero, I don't know. I'm just in my rhythm and flow. 0 to 180 is talking about quadrants 1 and 2. But -135, what quadrant is that in?
That is 2.
If this is 0, this is what? If we do negatives.
90.
This is -90. This is what? Negative.
Oh, okay.
So it's in what quadrant? Quadrant 3.
1, 2, 3.
Okay, so look. Here's 0 degrees, right? This is -90. This is -180, right? So -135 is here, but ours has to be in either quadrant 1, or quadrant 2, because we said 0 to 180. So it's not defined, not a function, not defined.
And so we use 0 to 180 instead of the -1 to 1 because the cosine inside is inverse.
Hang on, let's duplicate. We want to get rid of that. Delete. Are we missing something? It looks like we're missing something. Delete. Cosine. Say that again, your question?
The reason for why we use 0 to 180 instead of the -1 to 1 is because the cosine on the inside is our inverse.
Yeah. If we had the inverse on the inside, then we would use the -1 to 1.
And that applies to sine too.
Yeah, it's the same kind of, it's a similar technique. You just have to adjust instead of -90, instead of 0 to 180, it's -90. But the concept is essentially the same. Okay, so I think we got the first one. The first one was pi over 15. And the second one is not from 0 to pi, so then it's, oh, they got me. I was trying to catch this one. I made a mistake. So I got it wrong. Right here. So the angle -3 pi over 4 is not in the interval 0 to pi, but because the cosine function is even, cosine of a negative is actually the same as cosine of the positive. That's the definition of an even function. Anybody know the definition of an even function versus an odd function? So an even function means that if we did f of -x, that's going to be the same as f of x. An odd function means if we did f of negative x, that's going to be negative f of x, all right? Another way of looking at this means y-axis symmetry. This one. This means origin symmetry. So the cosine function is an even function. So when we do cosine of a negative, that's actually the same as cosine of the positive. So let's go back. I want to leave that error that we had. So I'm going to leave this as a reminder. That's wrong. Because cosine is even, we can do the following. Let's do this. So inverse cosine of negative 3 over 4, because cosine is even, this is actually the same as cosine of 3 pi over 4. We also didn't check it in our calculator. We should have checked it in our calculator. We would have gotten a result. Right? I'll show you in just a moment. So cosine of the negative is actually the same as cosine of the positive. So then 3 pi over 4 we said was 135. So then this is actually the same as cosine of 135 degrees. Now we're in quadrant 2. So then that results I think it's just x equals 3 pi over 4. Yeah, I think that's it. Let me look at it before we go forward. Yeah, just 3 pi over 4. Okay, there should be questions on that one. I know that was like a little bit, that one was a little bit of a trick. So that's, you'd have to be aware of even and odd properties of functions. Even means that it has y-axis symmetry. So the definition of a function being even means whenever we do f of a negative, that's actually the same as f of the positive. Okay, so then when we do f of negative 3 pi over 4, that's actually the same as cosine of the positive, then we can actually proceed. Right? I know that was a little bit back and forth. We just have to do the best you can. What's the time? 30 minutes. Okay. We're gonna stick to just this section for today. Let's go ahead and finish it out, and then we'll call it a day. We're not gonna leave, but we're gonna take a breather and maybe get some practice. So now the tangent function. Yeah, we can do that, but we at least need to finish this. So if this is the tan function, and in the spirit of restrictions on the domain, based on this graph, what restriction do you think we impose on the domain of tan in order to talk about inverse functions?
So then for the range, would it be negative?
That's the range, but what's the domain? What restriction do we impose on the domain? So it passes the horizontal line test. If you draw a horizontal line, it touches it infinitely many times. So
What was the question?
what restriction can we impose on the domain of the tan function? This is the graph of tan. What restriction can we impose on the domain of the tan function so that it passes the horizontal line test? Remember, for sine, we restricted sine from negative 90 to 90. We restricted cosine from 0 to 180. So based on this graph, what can we get rid of and keep so that it passes the horizontal line test? In other words, restrict the domain from where to where? That's, nope.
Oh, we're looking at this part.
The domain is the x, right? X, the x.
I think it could be really any.
Huh? Not any, just if we center the,
It's a defined set.
if you had to guess.
Negative 90.
Yeah, negative 90, 90, right? So if we restrict the domain from negative 90 to 90 interval, that means all the stuff on the left is going to go, all the stuff on the right is going to go, and we're just going to have that one S shape in the center. Then that one by itself will pass the horizontal line test, and then we can talk about inverse trig, inverse tan. Okay, so for tan of x, the domain, we're going to restrict it from negative 90 to 90. We're going to do it in parentheses instead of square brackets. The range, like it was stated a moment ago, is going to go from negative infinity to infinity. So then when we do this, inverse tan of y, this is our range, this is our domain. It just flips, right? So with those restrictions, we're left with just that middle piece. So you see the negative 90 to 90. The range goes from negative infinity to infinity. Okay, that was a journey. Let's keep going. We're almost there. So, yeah, so the domain of the inverse is all reals, and the range goes from negative 90 to 90. In the graphical sense, you see the red is the original, the blue is the new. Okay, we're going to let that be. Now we're asked to find the exact value. Again, so when we do these, let's do this thing again. So tan of x, we said the restriction goes from negative 90 to 90, open interval. So the range is as follows. We said the range goes from negative infinity. Let's clean that up. So this goes from negative infinity to infinity. This is our range. This is our domain for inverse tan of y. Okay. So that same initial setup like we always do. So now, let's do this. So we're going to say inverse tan of this negative root 3 over 3. I don't like that. That's kind of messing me up a little bit. So we got this root 3 over 3. Whatever. That's going to equal to what? Some x, right? Again, this. Sorry. So like, oh no. Because I'll be feeling like I'll be doing something really wrong. Okay. Let's do this again. So inverse tan of the square root of 3 over 3 negative. They said that's equal to what? X. Again, this means tan of some angle equals a negative square root of 3 over 3. Okay. I'm going to let that be for right now. I could go into that, but I'm not going to. So can you tell me tan of what angle gives us root 3 over 3?
Which using negative 90 to 90.
That discussion comes in when we do tan of inverse tan or vice versa, when we have the composite functions. Is it 60? Okay, so let's see if it's 60. So I'll work here. So let's say we want to do tan of 60 degrees, right? That's going to be the same as what? Tan is, okay. So this will be sine of 60 degrees over cosine of 60 degrees, right? So then from the unit circle, the 1, 2, 3, 1, 2, 3, what's the sine of 60? Okay, sine of 60, 1, 2, 3, 1, 2, 3, no. Sine is our y, right? Mm-hmm. Okay, so sine of 60 is square root of 3 over 2. Cosine of 60 is what, a half? So this result is just a square root of 3, but we wanted the reciprocal. So it's not, instead, if it's not 60, what do you think it might be? Instead of 60, let's do 30, right? So this one didn't work. We kind of did a low-key guess and check, but it's not really guess and check. Tan of 30, let's just do that one really quickly. This is going to be sine of 30 over cosine of 30. All right, sine of 30 is our y, 1, 2, 3, 1. So that's a half over root 3 over 2. This becomes 1 over root 3, and that's ultimately the square root of 3 over 3. So now we know the reference angle. We know that x is 30 degrees. But if we're doing inverse tan, let me think about it. So tan of what angle? So that x has to be from negative 90 to 90. So it looks like it should be a negative 30. So we can produce that negative. All right. So, and let's convert that to radians. So it's a little bit, you have to try it. Okay. So if we're saying that this is our x, let's convert this. So negative 30 times pi over 180. what is that, a 6 pi over 6. Okay, let's see if this works. Before we look at the answer, we're just going to check it in the calculator. All right? Negative root 3 over 2 over 3. So we're going to go mode, we're in radians. We're going to do inverse tan of negative square root of 3. What do we say, over 3? Over 3. 3. We're going to get, we should get a negative decimal. We got it. We said that that was negative pi over 6. So let's do negative pi over 6. And by the good grace of God, it's the same. Because if it was off, I was going to have it fail. I was going to be like, no. Guys, come back. No, but. Okay. So there should be questions. I'm going to pause for a moment. I know we're at that point of law of diminishing returns. I'm really just trying to wrap up this section. We still got a few slides, so just do the best you can. I'm pretty much doing this for the video at this point, so I just want you to. No, I mean, because that's enough. You know, I get it. It's enough. So, but we have our handouts. Okay, so just work, get those documents turned in, so I can give you credit. Okay, don't let those zeros persist on your Okay, and also it's a good idea to do your homework now. I would recommend do the homework on Pearson. If the book is one thing. If you're able to do it in the book, that's fine. But I would recommend to work on Pearson, and you definitely want to have a copy of the original question with your results, not just the score, but you need a copy of the question with the answer. You see what I'm saying? So get a copy of that. Either write it down or print it out. Okay, and bring that in the day of the exam. Okay, it's not for me. Let's duplicate this. Here we want to get rid of like this stuff. Yes, that can go. Oh, we got our work cut out in this one. Delete. Oh, come on. No. Oh, I'm going to have a hard time. There it is. Delete. 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 And let's duplicate. Let's get rid of all these annotations. Okay. So again, we have our work cut out. Just have to do your best and forget the rest. We got a result of negative pi over 6. I think that's it right there. Okay. I'm just going to let it be for now. Okay, so now this is where that whole, we got to look at the inside function comes into play. So the domain and range, we got to be clear about that stuff. Okay. Find the inverse function of this, and then find the range of f and the domain, and find the domain. Okay. Basically find the domain and range of f and f inverse. Okay. So let's do our usual. So if we consider the original function of tan, that domain we say goes from negative 90 to 90. In parentheses, the range we said was negative infinity to infinity. Then, and actually to kind of help, I'm going to do the following. I'm going to change this to red. We said this went from negative infinity to infinity. So now this is now our range. This is our domain of inverse tan of y. Okay, that's the first thing that we need to do. Scratch that. I was an autopilot. We're doing sine. We're not even doing tan. I told you, we're all kind of like at that point. So I'm going to clear these pen markings. Let's see. Find the inverse function. Oh, they want us to find the inverse. Okay. So given a function, how do we find the inverse of a function? Flip the x and y, right? That's an old college algebra thing. Okay, so that gave us the domain. It says it's restricted from negative 90 to 90. So let's find this inverse function. Let me think about it. Hopefully I'll get this one. So if we have y equals 2 sine x minus 1. Okay, so if we switch the x and the y, we're going to get x equals 2 sine y minus 1. If we add, we're going to get x plus 1 equals 2 sine y. So then we get sine of y equals x plus 1 over 2. So then f inverse is going to be inverse sine of x plus 1 over 2. We need to be clear about the range. Okay. Let me think about this for a moment. So now for this range, or for this domain, let's do the following. I'm going to try something. So if the original was restricted from negative pi over 2 to this, let's see. The first thing we did was, I think we just add 1 if, can we just add 1 and divide by 2? There's something that I'm missing. I'm going to look at the answer here just for the sake of time. So if y equals this, we get this, that's fine. So now to find the range, we solve this for this and use the fact that sine goes from negative 1 to 1. Okay, so in the original sense, the sine went from negative 1 to 1 right there. So sine of x equals y plus 1 over 2. That goes from negative 1 to 1. If we solve for the y, we get that it goes from negative 3 to 1. Okay, so I think I was going a little bit astray there. Okay, so just to kind of bring it home, let's actually use this color. So we're going to use the fact that sine of x, that range went from negative 1 to 1, right? So sine of x should be our y. Let me think about it. Okay, so on the left we have that y equals, I think I'm tired. Y equals that. We get, so the inverse was this. Okay, that's fine. Right. So if y equals 2 sine of x minus 1, okay, that's what we needed. Just to bring it home, right here. Come on. Okay. So the original was this 2 sine x minus 1. Am I doing this right? I keep feeling like I'm doing it wrong. I'm so tired. Okay. So now if we go negative 1 y to 1, right? Dang, I can't get it. I'm sorry. I'm really tired. I'm like in a fog right now. I'm just gonna rely on this part over here for the rest of it. Because what's the time? I'm also kind of rushing a little bit. Okay. So I'm gonna use, come on. Can we, there it is. So for the range, again, to find the range, solve y equals 2 sine of x minus 1. Really quick, I want to see the original. Y equals, okay, solve that. Okay. I'm going to rely on this slide for this one. It says that y equals 2 sine of x minus 1. And then we have that for sine of x goes from negative 1 to 1. So if we add 1 and divide by 2, okay, I get it now. I think I can do it. I'm going to go ahead and do it. Right here. Orange. Okay. So we're gonna say that y equals 2 sine x minus 1. And we're going to use the fact that sine of x goes from negative 1 to 1, right? So if y equals 2 sine x minus 1, if we solve for sine from there, add and divide, we get sine of x equals y plus 1 over 2, right? So then this means that negative 1 is less than or equal to this y plus 1 over 2, which is less than or equal to 1. Now we can multiply all parts by 2. We get negative 2 like this. And then subtract 1 from all of them. We get negative 3 is less than y, which is less than 1. So then that's our range. So what we're saying is that the domain of the original went from negative pi over 2 to pi over 2. And we're saying that the range went from negative 3 to 1. And then when we do the inverse, so if this is for f of x, when we do f inverse, this should be our range, this should be our domain. Okay, that was the whole point I was trying to get to, but I was like I said, I was in the fog. I know it was a lot of back and forth. You have to do the best you can. It's only like that because it's an introduction. If you look at it, you'll see it's not really that bad. It's not that bad. Okay, so look, right here. So again, to find the range, this is what we just did. To find the range, we saw for y equals 2 times sine of x minus 1, we isolated the sign. Because we know that sine goes from -1 to 1. So then when we isolated the sign, it was y plus 1 over 2. Then we put it into the range, and then we get this range. Okay. So then from there, so the range of the original is this or that. Okay, we did that. So then once we have the domain and range, we just flip them for the inverse. All right. Okay. Oh, that was it. Okay. And then another reason that was challenging because it was at the end of our stuff. Okay, we're gonna let that be. So I think we're done. Oh, wait. How many more slides? Okay, this is it. Solve this equation. Okay. I'm going to try to pull it all together. This is going to be it for the whole shebang. Okay. So now let's start here. Since we're doing inverse trig, what's always a good idea? Yeah, I'm just going to go with my first minus. So since we're doing sine of x, that domain goes from -90 to 90, like this. Okay, let's just keep going. So then the range goes from -1 to 1. So then when we do inverse sine, this will be our range. This will be our domain. Let me see if this is okay. I think this is fine. I'm going to let it be for now. So now if we have 12 inverse sine of x equals 3 pi. So if we divide, that means inverse sine of x equals 3 pi over 12, which is what? Pi over 4. All right? So if we have inverse sine of some x equals pi over 4, let me think about this. Okay, so let's continue over here. Again, inverse sine of x equals pi over 4. Again, this means x equals sine of pi over 4. What's pi over 4? Is that 45 degrees? Root 2 over 2? Is that right? Let me think about it. Okay, so I'm going to check this in my calculator first, right? Let me just check it in the calculator. We said the output should go from -1 to 1. I think we're okay. So let me do this in the calculator. So our claim is that x is the square root of 2 over 2. So we're going to say 12 times the inverse sine of root 2 over 2. Is that right? Sine of what angle gives us? Did I make something up? This means sine of, yeah, I think we're okay. So now let's do 12 times the inverse sine of root 2 over 2 and see what happens. So if we said 12 times the inverse sine of square root 2 over 2, we're going to get some decimal. That should be 3 times pi. Awesome sauce. Huh? Okay. She just sprayed in light and cheer. Okay. So I think that was correct. When I put it in the calculator, it actually worked out. Let me check this. Okay, let's do this really quickly. Keep. Yeah, I want to keep that. Let's duplicate this. And here, let me get rid of this stuff. We're wrapping up, so, just breathe and do your best. Not duplicate. Definitely hit up the tutor. Don't be afraid to use my office hours. Keep in mind, I'm offering extra credit for every hour you spend on my office hours, okay? From the current slide. Okay, let's see how do we do. Oh, and then one other thing. On this one, we need to delete the annotations. That one. Here. Okay, so when we did it, we said that x has to be the square root of root 2 over 2 to work. So now let's see how they do it. To solve an equation using inverse trig, first isolate the inverse trig. So we got the inverse. Oh, I feel like we're missing a slide. Okay, there it is. So we divided by 12. We got the power over 4. this again, that means x equals the sine of pi over 4. Sine of pi over 4 is the square root of 2 over 2. And I think that's it. That was an adventure. Okay? So I know it's intimidating, but I know also that you can do it. That's the only reason I'm going forward, because I know you can do it. It looks intimidating at first. If you work a few examples, again, I definitely would recommend working from Pearson. This is why I make Pearson available, because Pearson has like the video. It has video tutorials. It has view an example. It has the ebook. It has a lot of support, right? And it has multiple angles of the same things. I think if you all team up between you all, the tutors, and my office hours, it's going to click for some of you all. Hopefully everyone. That's the goal, is to get it to click for everyone. For right now, I want you all to just breathe, okay? Don't just put it down. Huh? You can do it, but I'm just saying for literally in this moment, just breathe for a moment. Like don't try to, just let it be, right? So when you get out of here, like breathe, eat, rest, probably do some exercise, some kind of physical activity. That definitely helps, like dance, run, jump, play, exercise, something. Maybe take a nap. Then whenever you wake up from that nap, that's the best time to look at this. If you try to do it now, you're going to be foggy. It's just going to make the experience worse. Just try to enjoy yourself for a little bit. Take a nap when you wake up. When you first wake up, that's when I recommend looking at this stuff. If you can hit the tutor, do what you can on your own. You can use the book. The book is fine. I would definitely recommend Pearson though. Pearson is another perspective. Do what you can on your own. Use Pearson. Bring your materials to the tutor. If you want extra credit, attend my office hours. For every hour you spend in my office practicing, I'll offer extra credit for you. And again, I can't stress it enough. The day of the exam, bring your homework notebook with your notes. So have a copy of your original question with whatever supporting work that you've done. Not just scores. You want to have a copy of that stuff for a quick homework notebook check. It's for you. It's not for me. Any questions about anything? Okay, lovely people. I know that was intense. I want you to breathe. Go ahead. Yes. Go ahead.
So for number 2, it's at for domain.
You talking about the quiz I just passed out at the beginning of class?
Yeah, it gives you the domain, but it tells you the state range.
You said number 2? Reading quiz. This one, right? It says the domain of a one-to-one function is 6 to infinity. State the range of its inverse. Right?
So the 6 to the infinity, that's the domain.
Okay. So remember today, like all day today, we did stuff like, okay, if we consider, I don't like that. Hang on. I'm coming. Come on. Okay. So like, let's just back up. So today we did stuff like we say the sine of x, and we considered this the domain, and we said that went from where negative 90 to 90. I'm just using this as an example. And then the range went from negative 1 to 1, all right? So then when we did inverse sine of y, this was our range, this was our domain. Is that fine? So it says the domain of a one-to-one function. So to kind of apply it to this one, let's just change this negative 90 to that domain, right? So we're going to change it to 6 to infinity, just to force it to match. So it says the domain of a one-to-one function is 6 to infinity. State the range of the inverse. So now, based on that, can you tell me the range of the inverse? Just like that. Does that make sense? Okay. Other questions before we go our separate ways? So again, that's what I mean by like at first glance it's intimidating, but if you just stick with it and keep working and keep pushing, it's gonna click, it's gonna turn over. Don't be afraid. Keep pushing, keep going. Do your best, forget the rest, don't stress, and be blessed. Okay, lovely people. It's been real. I'll see you Thursday, okay? All right. What's today?
Thursday. Tuesday.
I'll see you Tuesday. So have a good weekend, okay? Okay, have a good weekend. I'll see you Tuesday. I told you, it's like I'm tired. Wait, are you done? Yeah, keep it so you can help others, okay? That's how I want you to keep it. Okay, so work with your classmates, okay? Turn it in first thing on Tuesday. That, and also turn in the thing that was in your email, okay? All right, lovely people. Until next time.